Download this code from codegive.com, link in the description below. Certainly. Google's work on enhancing the Linux kernel, particularly for improving TCP performance, involves various patches and optimizations. Below, I'll provide an informative tutorial on how Google has approached TCP performance improvements in the Linux kernel and a code example to illustrate. Overview of TCP performance improvements. TCP, Transmission Control Protocol, is a core protocol of the Internet Protocol Suite that ensures reliable, ordered, and error-check delivery of data between applications. Performance improvements in TCP can significantly enhance the user experience, especially in high bandwidth or high latency environments. Common TCP performance enhancements. 1. Congestion control algorithms. Modifications to how TCP handles congestion can improve throughput and reduce latency. Algorithms like BBR, bottleneck bandwidth and round-trip propagation time, have been introduced as alternatives to traditional algorithms like cubic. 2. TCP window scaling. In high-bandwidth environments, increasing the TCP window size allows more data to be in transit before waiting for an acknowledgement, which can improve throughput. 3. Selective acknowledgements, SAC. This feature allows the receiver to inform the sender about all the segments that have been received successfully, enabling the sender to retransmit only the missing segments. 4. TCP Fast Open. This feature reduces the latency of TCP connections by allowing data to be sent before the connection is fully established. 5. Optimized buffer management. Efficient handling of buffers in the kernel to reduce memory usage and improve performance under load. Setting up the environment. Before applying patches, ensure you have the necessary development tools and kernel source code. 1. Install kernel development tools. Bash. sudo apt-get install build essential Linux headers $. 2. Download the Linux kernel source. You can clone the kernel source from the official repository. Bash. Git clone https://git.kernel.org/pub/scm/linux/kernel/git/stable/linux.git. cd Linux. Applying TCP performance patches. Google has contributed patches to the Linux kernel over time. For this example, let's assume you want to apply a patch for BBR congestion control. 1. Check out the stable version. Bash. Git check out v5.10 or any stable version you choose. 2. Apply the BBR patch. You can create a patch file based on the changes, but an example of enabling BBR in the kernel can be done through configuration. Open the kernel configuration menu. Bash. Make menu config. Navigate to Networking Support -- Networking Options -- TCP, BBR. Enable BBR by selecting it. 3. Compile and install the kernel. Bash. Make $, nproc. sudo make modules_install. sudo make install. 4. Update bootloader. After installation, update your bootloader, like grub, to include the new kernel. 5. Reboot. Reboot your system to use the new kernel. Example code, enabling BBR. To enable the BBR congestion control algorithm after booting into the new kernel, you can execute the following commands. Bash. Enable BBR. Echo BBR sudo t/etc/modules load.d/bbr.conf. Set the congestion control algorithm to BBR. Sudo sysctl/wnet.ipv4.tcp_congestion_control equals BBR. Verify that BBR is enabled. sysctl.net.ipv4.tcp_congestion_control. Monitoring TCP performance. To monitor the performance improvements, you can use tools like iperf, netstat, or SS to check throughput, latency, and other metrics. Example using iperf. 1. Install iperf. Bash. Sudo apt-get install iperf. 2. Run iperf server on one machine. Bash. iperf s. 3. Run iperf client on another machine. Bash. iperf c server_IP_address T60. This will help you measure the TCP performance before and after applying the patches. Conclusion. Enhancing TCP performance in the Linux kernel involves various strategies, including implementing advanced congestion control algorithms like BBR. By applying relevant patches and configuring the kernel appropriately, you can significantly improve the performance of TCP on your system. Always refer to the official kernel documentation and mailing lists for the latest patches and performance improvements contributed by the community. Tutorial: Google Patches for Linux Kernel TCP Performance. Google has been actively involved in improving the performance of the Linux kernel, particularly in the area of TCP, Transmission Control Protocol. These improvements help enhance network throughput, reduce latency, and make better use of system resources. In this tutorial, we will discuss some of the performance enhancements that Google has contributed to the Linux kernel, especially in relation to TCP. Overview of TCP performance enhancements. 1. TCP BBR, bottleneck bandwidth and round-trip propagation time. BBR is an advanced congestion control algorithm developed by Google. It aims to maximize bandwidth while minimizing latency. Unlike traditional algorithms, like TCP Reno or Cubic, which react to packet loss, BBR actively measures the available bandwidth and round-trip time, RTT, to optimize sending rates. 2. TCP Fast Open ***. This feature allows data to be sent before the connection is fully established, reducing latency for repeated connections. It uses a cookie mechanism to enable this optimization. 3. TCP Selective Acknowledgement, SAC. This feature allows the receiver to inform the sender about all segments that have been received successfully, enabling the sender to retransmit only the missing segments. 4. TCP Window Scaling ***. This feature allows for larger TCP windows, increasing throughput on high-latency connections. Setting up and using Google TCP enhancements. To take advantage of these features, you may need to ensure that your Linux kernel is up to date and configured to use these enhancements. Below, we will guide you through the steps needed to check for these features and how to enable them. Step 1. Check your kernel version. You can check your Linux kernel version using the following command. Bash. uname. Make sure you are running a kernel version that supports the features you want to enable. Generally, kernels 4.9 and later have good support for TCP performance enhancements. Step 2. Enable TCP BBR. 1. Loading the BBR module ***. You can enable BBR by loading the TCP_BBR module. Bash. sudo mod probe TCP_BBR. 2. Setting BBR as the default congestion control algorithm ***. You can set BBR as the default by modifying the sysctl.conf file. Bash. echo net.core.default_disk equals fq sudo ta/etc/sysctl.conf. echo net.ipv4.tcp_congestion_control equals bbr sudo ta/etc/sysctl.conf. Then, apply the changes. Bash. sudo sysctlp. 3. Verifying BBR is active *. You can verify that BBR is active with the following command. Bash sysctl.net.ipv4.tcp_congestion_control. It should return BBR. Step 3. Enable TCP Fast Open. To enable TCP Fast Open, run the following command. Bash echo 1 sudo t/proc/sys/net/ipv4/tcp_fast open. To make this setting persistent across reboots, add the following line to your sysctl.conf. Bash net.ipv4.tcp_fast open equals 1. Step 4. Enable TCP SAC and window scaling. These features are usually enabled by default, but you can verify and enable them as follows. 1. Check SAC *. Bash sysctl.net.ipv4.tcp_SAC. To enable SAC. Bash echo 1 sudo t/proc/sys/net/ipv4/tcp_SAC. 2. Check window scaling *. Bash sysctl.net.ipv4.tcp_window_scaling. To enable window scaling. Bash echo 1 sudo t/proc/sys/net/ipv4/tcp_window_scaling. Step 5. Testing performance. To test the performance improvements, you can use tools like iperf or netperf to measure TCP throughput and latency before and after enabling these features. 1. Installation of iperf *. On Ubuntu, install iperf using bash sudo apt-get install iperf. 2. Running iperf server *. On the server side, run bash iperf s. 3. Running iperf client *. On the client side, connect to the server and measure performance. Bash iperf c server_IP_address t30p10. This command will run the test for 30 seconds with 10 parallel streams. Conclusion. By following this tutorial, you have learned how to enable and configure Google's TCP performance enhancements in the Linux kernel. Features like TCP BBR, Fast Open, SAC, and window scaling can significantly improve network performance, especially in environments with high latency or variable bandwidth. Always ensure to monitor and test the performance impacts of these changes in your specific workload and environment.